Hello. Hello. Hello.
Hello, hi.
Yeah,
Yes,
hi,
sir.
Arjun. Yep. Okay. Let's start at recorded, right? Recording, right? Okay. So, guys, today's concept is pretty much important. Okay. So, the reason is that we are starting the new module. The name of the module is machine learning. Okay. So, this is to. So, I hope you can able to get it some more information regarding about machine learning. So as of now, you guys are thoroughly understood the Python and the stats, right? Okay. So in future, after I complete the machine learning and SQL and Tableau also, I can train you. Okay. So this time I would like to talk about machine learning. So you know, in this particular machine learning, uh, if I done the machine learning, then you can easily do any kind of data science projects actually. And yep. So let's go for understanding the machine learning. So before we start about machine learning, okay, before we start about machine learning, okay, see, we might be getting some words, right, like deep learning, right? And we might be getting some kind of artificial intelligence, right? Artificial intelligence, right? AI. So you can call it a AI, and you can call it a deep learning, and you can call it a ML, machine learning. Okay. So let's talk let's talk what exactly the deep learning. Or first we'll talk about machine learning. Mm, let's talk about machine learning. So what exactly the machine learning is doing? What exactly the machine learning is doing? Can anybody? Can anyone can explain it?
Machine learning means how the machine behavior once we comment
Sorry, mission behavior.
the machine's behavior according to our code
Mm-hmm.
or statement or education.
Mm-hmm. So I just give the small difference between the machine learning program and traditional program. Okay. So
Okay.
you can call it a normal program. Okay. So you wrote a program for addition of two numbers. Let it be considered addition of two numbers. Okay. See, this is my program. So when we wrote the program for addition of two numbers, there you should providing the input, right? And we are providing the input to, right? So what could be the output we are getting? It is addition of two numbers, right? So x1 is one number, x2 is one number. Then this is the program, it can performing the x1 plus x2, then we are getting the result of x1 plus
X1
x2,
plus
right?
X2.
Okay, this is normal program, we can write it, right? So what exactly the machine learning is doing? Let me consider this is my machine learning algorithm or program, ML program. Okay, so here what exactly this thing is doing, we have some kind of set of inputs as well as set of outputs. We have some kind of set of outputs and corresponding, so we have set of inputs and corresponding outputs, we have it, right? So then we are giving some set of inputs and outputs to my ML program. This time what it can do, okay, this time what it can do, it can be creating the program based upon this particular pattern. So here inputs is, for example, 5 and 6, output is 11. So here 10 and 20, output is 13. Okay, for example, here input is 35 and 40, output is 75, right? Like this, we have some kind of set of inputs and outputs are there. This set of inputs and outputs, if I am giving to my machine learning algorithm, it is go for creating the code. Okay, it is creating some kind of code that we are calling it a model. This is the model, is your program or else model, whatever it is. Okay, to this particular model, okay, see what you can do in new inputs. For example, if I'm giving the 10 comma 50, then you will be getting output is 60. Okay, here did you write any kind of additional program here? Did you written any kind of addition program here?
No.
No, right? But we are getting output for the addition or not, for
Yes.
any new inputs. So this exactly the machine learning is doing. Okay, machine learning means based upon historical data. Okay, based on some kind of historical data. Okay, the program here, the machine learning program, or it is also one program. Okay, the software or the mission or code, whatever it is, the software can learn itself. Yes or no? It is learning addition of two numbers or not? This is my historical data. If I'm giving this historical data to ML program, which is generating additional program or not? Okay, so which means that what it is learning or not? Okay, this is doing addition, right? So it is learning or not? Software can
Learning.
learn itself. That we are calling it say machine learning. Clear? So as of now, this is fine. So
So
where?
machine learning, basically, machine learning basically the algorithms, that
Mm,
you're showing, they're
yes,
just using that programming, right? It's not doing any additional, correct?
yes. It just creating some kind of pattern or models based upon your inputs. Okay,
Mhm.
based
Okay.
upon your input data set, it is creating some kind of model. That model we can use for do some kind of a new input to learn
Mm.
some new things. Okay,
Okay.
so let's talk about deep learning. So deep learning, it could be, you can say it's a advanced of machine learning. Okay, so in case of machine learning, you have some kind of historical data, and based upon that historical data, the ML algorithm, it will go for creating the model. Okay, and if any new inputs we are getting, so you will be getting output, right? Okay, the same things we can do with help of the deep learning, but not like, not like in a traditional machine learning algorithm. What exactly it will do, it will replicating of the how the human being is learning with experience. How the human being is learning with, okay, is with his own. In the same way, the machine also can be learns itself. That means it is replicating the human brain. Okay, so how the human brain is learning for new things. Okay, for example, I just give some question. Do you know, if you put some kind of your if I put some kind of hot thing in your hand, would you like to put yourself, right? Your hand can took yours towards your side, right? Okay, before I put some heat thing on your hand. Yes or no? Did you got my point?
No.
No, what I'm trying to tell you, just consider this is some hard thing. Okay, um okay, so if I put on your hand, what happens? Your hand can be burn itself, right? Little bit.
Right.
Okay, see, you're not experienced before it. You're
Hmm.
not experienced with any heart or any heat thing, right? So by the time if I'm trying to be put some hot thing on your hand, will you took towards yourself or not?
Yeah, we don't touch it.
We won't touch it, right? We won't touch that hot thing,
Yes.
right? But you're not experienced, but you can able to understood, okay, this hot thing can make it some kind of problem with my hand. Like that means what, you're sensing something or not? You're sensing some
Yes.
hot thing, right? And
Right.
so in the same way, so the mission or the software you're going to be building, okay, how the human is thinking or human brain is learning itself with some, for looking something and understanding, okay, itself, okay, in the same way we are going to be building some kind of softwares with replication of the human brain, that exactly the technology behind the deep learning. Okay, so which means that here what happens, how the deep learning is working. So here we have a lot of inputs. Okay, this is a lot of inputs. So you can say that it's your hidden layers. That means your hand, it might having some kind of sensing organs, right? Those we can't see, right? So that we can say that it's a hidden layers. Okay, so let me consider this is a brain, right? So in between, from your hand to your brain, there are a lot of sensors are there, lot of layers are there. Okay, there are a lot of layers are there. Okay, in the same way, in the same way, so we are going to be creating a lot of hidden layers. We are going to be creating a lot of hidden layers in your program, and we are giving these inputs with some bias, whatever it is, and each and every hidden layer, it is generating some output. That output can be carried as input for the next layer. Okay, here this hidden layer also can be generating some output, and it can be giving input for the next layer and next layer hidden layers. In the same way, this hidden also can be generating some output, and it was giving out that output to input for the next layer. This will be, this will be for this, each and every neuron can be connected with all other hidden neurons. This is the way, this is the way, okay, this is the way we are going to be getting some kind of output. This kind of process we are calling it a forward forward direction. Okay, forward feeding. So in the meanwhile, if you want to, you might be getting some output, maybe that output is having some kind of error. Okay, so to updating these inputs and everything, okay, those things we can say that's a backward direction. So in case of machine learning, the difference between the machine learning and deep learning is, in machine learning we have only forward direction. We don't have any kind of backward propagation. We have only forward propagation. We don't have any kind of backward propagation. But in case of deep learning, we have forward propagation, we have backward propagation. Both propagations are having inside of the deep learning technology, so that we can achieve the output in a good accuracy. In case of machine learning, you can get some accuracy, but it's not exactly, it is not replicating your output, actually not 100%. Just 95% of 95% of accuracy only we can achieve with help of the machine learning. But the same example, same problem, if I do with help of the deep learning, because of this forward propagation and backward propagation, we can achieve the output with 99.9% actually. Clear? Clear or not? So that is the difference between the machine learning and deep learning. Last 2 or 3 years back, most of the companies in a data science, they are going to be using the machine learning only. Deep learning is not using at all. Okay, but every company, they are introduced that artificial intelligence. Artificial intelligence, it's a combination of the both, not only machine learning. Okay, so artificial intelligence means it's a combination of the deep learning and machine learning. So that we are calling it artificial intelligence. Okay, I just want to tell you what exactly the artificial intelligence. In artificial intelligence we have which exactly replicate of the human brain, right? Okay, human brain in the sense, see, we can do the multiple tasks, we can do the multiple task actually, but not not exactly human, not exactly human. So if, for example, human being can do the work in a perfect manner, right? Okay, in the same work, and human being can do the multiple tasks, right? For example, as a person, one person can do the multiple tasks, right? In the same way, you can create the software, and the software can do the multiple tasks, but it is not exactly the human achievements. Okay, but here you can create only one application, we can create only one task, it could be better than human, that we already achieved. This one also we achieved. Okay, but most of the scientists are trying to do actually. So we have to go for do the multiple task actually. Multiple tasks, save exactly human outputs, human replicate. This is not still we are not achieved. This is very dangerous. If a software, if a machine is software, if it is doing multiple tasks better than or equal to the human being, then it could be the problem. So we are getting the competition, okay, with human being and computer science. Okay, so that we are not achieved, but most of the scientists are trying to do that particular thing actually. Okay, so there could be some kind of advantages, disadvantages we have it. So if we created only one application better than human being, that's okay, we can handle it. We can performing the multiple tasks, not exactly human being, that is also we can handle that particular software. If you want to modify that, you can do it. But something, if it is replicating of you, which means that it's a very dangerous, right? So this kind of things actually. So this is difference between the machine learning and deep learning artificial intelligence. In a data science, now we are talking about data science. In a data science, how where the machine learning is working, that I want to tell you actually. Okay, so in case of data science, you have we can use the data science in a different domains. Like you can able to go for use in no, finance domain, insurance domain, or else banking domain, sales domain, marketing domain. Okay, or healthcare analytics. We can use in healthcare domain, or else we can use in manufacturing. Okay, we can use in HR analytics. So different areas we are going to be using the data science for that one. Okay, we are doing only one task, right? So that machine learning is fair enough actually. Okay, so in case of based upon the problem statement, what exactly we will do, we would like to go for collecting a lot of data. Okay, we would like to go for collecting a lot of data. This is the data. Okay, first what you should do, we have to be process, we have to be process, data processing, or people can call it a data mining, or people can call it a data wrangling. Okay, so once the data is processed in a good manner, because of it's a raw data, this is the raw data. When you process it, then you will be getting the some kind of good sense of data. Okay, this is the good data only we would like to go for apply the on machine learning. Okay, when you're applying different machine learning algorithms, if you're applying that particular good data with help of any one of the machine learning algorithm, it will be go for creating the model. Okay, so after you creating the model, the next step is which is validating that model. If validating is not good, model validation is not good. Okay, if the model validation is giving the bad, okay, bad results, then we would like to go for change the new machine learning algorithm. Again, we can train it, and you are going to be creating the new model, and the model is validating, again it is not giving the good results, then again we can able to change it, the machine learning algorithm. This is the step, is keep on doing it until unless you are getting the good model for different algorithms. Once the model validation is good, if the model validation is good, then you would like to go for okay, use. If then if the model validation is good, then this is the model only we would like to go for deploy into the production. Okay, then we can use in real time. This is the model. Okay, if and only if the model is validated good. So this is in this particular area. So machine learning is playing a crucial role, and for the data processing, we are going to be using the Python. Okay, and for model validation, other stuff, we are going to be using the statistics. Clear? Is it clear? For deployment, other stuff, we are going to be using some kind of cloud related thing. I think in which area, which thing is involving. I hope you understood, right? And the data we are coming with the different sources, that it could be database actually. Okay, in case of data wrangling, and before doing this particular analytics or creating the model, if you want to visualize or understanding the data, then a Tableau other stuff will help you. Okay, so this is the flow chart, or this is the workflow of the data science. Okay, clear, right? So in this particular area, we are going to be understanding the machine learning. I hope you already understood what exactly the machine learning. I hope you guys are understood what exactly the machine learning, right? So now we'll try to be go for understanding the what type of machine learnings we have it. Basically, there are three type of machine learning algorithms are there. The first one is the supervised machine learning algorithm. Okay, second one is unsupervised. So this is the two things is enough for for data science. This is the two things is enough for data science. But we have reinforcement is there, which is not for data science, which is for artificial intelligence. When you want to go for learn some new thing, if you don't have a data, then reinforcement will help you. But most of the data science problem will have a data, so that we are going to be using the supervised or unsupervised. So in case of supervised and unsupervised, here we have some kind of label data is there. We have some kind of labeled data in the sense we know that what exactly you are going to be predicting it, output variable. So you know that you have a label data. So when we have a label data, so based upon that particular label data, again we have a two type of supervised machine learning algorithms are there. The first one is the regression. So in case of label data, it is continuous data. If the label data is continuous, then we would like to go for regression supervised machine learning algorithm. If the label data is the categorical, if the label data is the categorical, then we would like to go for using the classification algorithms. Okay. If you don't have any label data, you don't have any kind of output variable. Okay. You don't know what exactly doing your prediction. Okay. But you have data. So with the help of that particular data, based upon the characteristics of that particular data, we can use this particular supervised. Okay. Here we don't have any kind of labeled. Okay. Here we have different concepts or different clustering algorithms like k-means clustering and hierarchical clustering. Okay. And db scan, different kind of algorithms we are going to be using in unsupervised. And coming to the regression, we have multiple different algorithms are there in a regression. In regression, we have multiple linear regression or simple linear regression, polynomial linear regression, and decision tree regression, random forest regression. Okay. And different other type of regressions we have it. When it comes to the classification, very important algorithms are logistic regression. The name is the regression, but it could be used for classification. Okay. And svm, support vector mission, and knn, k nearest neighbors, and random forest classification, XGBoost, okay, decision trees, Navi base algorithms, like different kind of algorithms which comes under the classification actually. Okay. So this is what these are the algorithms only we are going to be understood for upcoming sessions. Okay. So in next session, what exactly we will do actually, I would like to go for explain the multiple linear regression, and I would like to go for explain multiple linear regression in a mathematically. Okay. And I can do the project on it. I will explain a project how I am doing that multiple linear regression, and so entire thing, even statistics also will be applicable in this particular area. Clear? I hope you got it my point. If you have any question, please let me know. This is for today's session, guys, and hopefully you catch my point, and we'll catch up next class for continuation of the multiple linear regression.
Thank you.
Yep. Bye. Take care.
Anjan,
Yes.
I missed a few classes actually. I was
No problem.
backward.
No problem. No problem. That is a statistics part only. Don't worry about what you missed it. Okay. And so if we have a time, then you can attend the one more statistics batch. Okay. It was your night time around 10 p.m. if you're okay.
Yeah.
Otherwise, I can share that particular recordings as well. Okay.
Yeah. Okay. Yeah.
Bye. Take
Thank
care.
you. Bye.